All right, so we're talking about phase shift, meaning when the graph moves horizontally to the left or to the right, okay? All right, to figure out how much the phase shift is, we use C and B, all right? In actuality, it's negative C over B. In reality, the way you figure out phase shift is this. So if you have y equals 3 sine 2x plus pi, let's say, all right? What we do in order to figure out how much it's moved to the left or to the right, you take this, set it equal to 0, and then you solve. Negative pi over 2, right? All right, so we got negative pi over 2. All right, so let's take a better look at this. The 2 is our b. The pi is our c, right? In here, what did we get? We got negative c over b, right? Because when you solve that term, you're always going to get negative c over b. So the books always give you this shortcut, but that's just one more thing to remember. Negative c over b, negative b over c. On the test, you might get it mixed up. So I never do it that way. When I want to figure out how much the phase shift is, I just take the term in the parentheses, set it equal to 0, solve for x, and that's it. That tells me how much it's moved along the x-axis. If it's x equals negative pi over 2, it means it's moved to the negative direction, pi over 2 units. Okay? Yes?
What if you don't have a C value and you, like, let's say just have, like, B as 2x?
Then there's no phase shift. Because if it was y equals 3 sine 2x, you can still do 2x equals 0, x equals 0, no phase shift. So it's moved only when the C value is other than 1. All right? Okay, so let's try to graph some with a phase shift. Here what we're going to do is state the amplitude, the period, the frequency, and all that stuff. So let's just start. How much is the period of this function here? The period, the amplitude. It's 2. The amplitude is 2. And the period is 2 pi over what? 5. That's it. The frequency, you don't have to do any work for the frequency. Just take the reciprocal, 5 over 2 pi. Okay. Phase shift, we're going to do 5x plus pi over 4 equal to 0. 5x equals negative pi over 4. Divide by 5. X is negative pi over 20. What does this mean? Where has it moved? To the left, how many units? By pi over 20. So 1/20th of a pi. So it moved to the left a little bit. Okay? All right. Now we're going to graph. Here's what we're going to do. We're going to take the term inside the parentheses here. And just like we did before, we're going to bound it in between the default start and end of the period of the sine. So from 0 to 2 pi. Pi over 2? Pi over 4. Okay? So whatever's inside the parentheses. And it's always going to go from 0 to 2 pi for the sine because the default sine starts at 0, ends at 2 pi. Now we're going to solve this. So subtract pi over 4 from everywhere. We get negative pi over 4, 5x. Okay, here, my shortcut to doing this, did I tell you guys this before? I don't remember. Whole number added or subtracted to or from a fraction. So whole number and a fraction. The denominator is always going to be the same as the denominator you have. And now here's what I do. 4 times 2 pi, always multiply that way. That's 8 pi. And then add this way, 8 pi and negative pi, 7 pi. Okay? That's how I that's how I do it. Yes? We're good with that? Okay, now we're going to divide by 5. Divide by 5, divide by 5, divide by 5. So finally, this is negative pi over 20, x 7 pi over 20. Okay, that's going to be important. Why? Let me tell you what these mean. This is where the cycle begins. So, beginning of cycle. This is the end of the cycle. Okay? So, now I draw the x-axis. Here, I put the beginning of the cycle, negative pi over 20. And then I'm going to go 4 marks over. In order to give myself some space, I'm going to count doubles. So 1, 2, 3, 4. I'm just going to spread it out. Here is the end of the cycle, 7 pi over 20. Now, the sine function that we're graphing is going to start and end between the first and the last point. Okay? What was the period of this function? No, the period of this function. Oh, I'm sorry, 2 pi over 5, you're right. That means the distance between here should be 2 pi over 5. Is it? I promise it is. If you take this, let's just try it. If you take this minus that, 7 pi over 20 plus pi over 20 is what? 8 pi over 20, which is how much? By 4, 2 pi over 5. It's this minus this, so it's minus minus plus, right? 2 pi over 5. So do you see that? The distance between is 2 pi over 5. That's where the period is. Okay, now what you're going to do is you're going to go and mark the midpoints here. Okay, so for the midpoint here, it's going to be the middle of the 2 points. So what I do is I add negative pi over 20 plus 7 pi over 20 and then divide by 2. Right? How do you find midpoint? Add, divide by 2. So if I want to find the middle of these 2 points, add, divide by 2. This is where you get into a little bit of math, but it's okay. It's fun. We can do this. So this is 1/2 times 6 pi over 20, and that's 3 pi over 20. So that's 3 pi over 20. Okay? Now I'm going to find the midpoint of the first here, that point. So what am I going to do there? It's going to be 1/2 negative pi over 20 plus 3 pi over 20. This is 1/2 2 pi over 20 pi over 20. Okay? Then I try to color code these as much as I can so you can follow along later. Here, it's going to be 1/2 of, okay, so if it's the midpoint of these two, the green and the black, you add the green and the black, divide by 2. All right? So 1/2, 3 pi over 20, 7 pi over 20, 1/2 of 10 pi over 20, 5 pi over 20. We're good? Okay, where does the y-axis go? In between these, right? Do you see how the x-axis, the y-axis goes in between those? Okay. Because it's going to be at the 0, and you see how these are completely symmetric, right? Negative and positive, so right between is 0.
So the y is always at the 0, and you can just start on any side of the
Correct. I do the y-axis last because it's easier to do it that way. Okay, now, this is a sign. That means the first point is on the x-axis itself, right? The amplitude is 2, and it's positive 2. So that means from 0, I gotta go up, not down. So here's what I do. If the amplitude is 2, I just go in and I put points. Look, 0, maximum, no, not there. Sorry. Okay. 0, maximum, 0, minimum, 0. So you see how it oscillates? Yes? Not in this case. Yeah.
Oh, so you're going like.
Why did I put the y-axis here? Okay, and there we have it. All right, and here it's going to be 1, 2. Okay, and there you have it. Questions? Next one. Here we go. Amplitude, period, blah, blah, blah. Okay, take a look here. All right, what is the amplitude here? 1/2. It's a small amplitude this time.
What does the frequency give us when we're graphing?
The frequency, what it does is, suppose you were standing here, right? And looking down at the wave, and you have a timer, and you're going to count, let's say in 1 second, how many crests pass by you. Correct. Yeah, when you're graphing, no. We just use the period. Okay, so here the amplitude is 1/2. What's the period? 2 pi over 1, which is just 2 pi. What's the frequency then? 1 over 2 pi. Make sure the pi is in the denominator. Phase shift, x plus pi equals 0, x equals negative pi. What does that mean? Everything's moved to the left. How many units? Pi units. And now I've got this here. What does that do? That is my vertical shift. So everything is now going to move up 1. Okay? So that's a vertical shift.
So it would start up 1 more?
Yes. Yeah. We'll get to that in a minute, and I'll show you exactly how I want you to do it. Okay. This is a sign again. I'm going to take the stuff in the parentheses, and I'm going to bound it between 0 and 2 pi. And now when I subtract pi from everywhere, I get negative pi x pi. So on my x-axis, all right, here's negative pi. Again, 1, 2, 3, 4 is pi. Okay, so beginning and ending. In how much space is there? How many units are there between negative pi and pi? How many units? There are 4 spaces, but how many units? What's the distance? 2 pi, right? From negative to pi, that's a distance of 2 pi. Is that the same as my period? Yeah, it is. So it's the same. Okay. Right. So let's now find the midpoints. First midpoint here, the midpoint between negative pi and pi, we add and divide by 2 is 0. This midpoint here, halfway between 0 and negative pi. Negative pi over 2. If you can see it, all the more power to you. If you can't see it, I add, divide by 2. I add, divide by 2. Here, I add, divide by 2, pi over 2. Okay. Now for the vertical shift. Where is the y-axis here? It's on the 0. Okay, now look. Sinusoidal functions oscillate, and they oscillate around an axis. Here, there is a vertical shift upwards by 1 unit, okay? That means the axis of oscillation is 1 unit up. So here, okay, y equals 1. That's the axis on which things are going to oscillate now. Okay, now, my first point is at negative pi. This is a sine. It starts on the axis. So my first point is here. Then up half a unit. Then back to 0. Down half a unit. And back to the axis. And so now I have that. And that is just a beautiful graph. In this problem, let's go backwards. Now I've given you the graph. Can you come up with the equation for it? Okay? Well, of course you can. All right. Write an equation that corresponds to the following graph. Okay, so first we want to determine, is it a sine or a cosine? The easiest way to do that is split it down the middle vertically. So that's here. All right? And if you look on y equals 0, x is 0, so you say, you know what? Okay, I could work with a sine. In actuality, if it's between sine and cosine, you could always do either or, because the sine is just the same as the cosine with a phase shift of pi over 2, okay? But let's not complicate things for this problem. Let's just work with the sine. Okay, so once I've determined that it's a sine function, I say, okay, what does an equation for a sine function look like anyway? That's what it looks like. So now I get to determine the A, the B, the C, and the D. All right? A is the amplitude, and you can only find the amplitude after you split it down the middle. It's the distance from the axis to the top. Question. Gabby, question? I split it down the middle here. And if you go on the y-axis, do you see how at x equals 0, as y equals 0, it's starting on the axis? That's a sine. If it was a cosine, it would start up here or down here. Okay? Okay, so now the amplitude looks like it's a 4. And because from the axis of rotation or the axis of oscillation, it's going up, it's a positive 4. Another one that's easier to see, or it's more straightforward, is the vertical shift. And you can see here that the axis of oscillation has shifted down from the x-axis by 2 units. So D is -2. Okay. Now I need to figure out B and C. Is there a C? Is there a phase shift? There is no phase shift because on the axis, like it's starting right on the axis, not to the left or right of it. So that tells me that C is 0. Okay. For B, I need to figure out what the period is. To figure out the length of the period, you just have to pick two identical points and figure out the distance between them. So I could pick the point here and here, and that tells me that it's a distance of how much? 4 pi. I could also pick this, and that distance will also be 4 pi. Or this and this, all right? Two corresponding points. So the period is 2 pi, 4 pi. Now, what is the formula for the period? It's 2 pi over b. And that is 4 pi. Okay, so now I just have to solve for b. How much would b be here? If this was a 1, it would be 2 pi over 4 pi. One half. Okay, so now I could put it all together. Y equals 4 sine b half x plus minus 2. Hang on, let me finish. If this ends here, you can get away with no parentheses. But when it's half x minus 2, you don't want to leave anything up to chance. Put parentheses where they go. Okay? Questions? Yeah. Let me get Yonatan first, and then I'll get Gabby. I'll pass, yes. Gabby. So we're going to write another function given some of this information. This time we're given the period, the amplitude, and a point that it passes through. So this is a little bit different. Amplitude, that gives us, like in the case of the amplitude, most of the time you just have to tell you. They tell you. Okay, so it passes through the point pi, comma 2. So x is pi, y equals 2, right? Sorry. Okay, so let's first deal with the period. 2 pi over b is equal to 4 pi. Now, in actuality, it's 2 pi over absolute value of b, right? In the first case, we knew the orientation, so we didn't have to deal with absolute values. But here, absolute value of b is equal to 1/2, right? When we solve for b. This means b could either be negative 1/2 or positive 1/2. Okay, what does that mean? Y equals a sine bx, right? There is no phase shift here. We're not given any information. So this is y equals 2 sine bx. And it could either be 2 sine half x or negative half x, and that makes a difference. So how do we figure that out? With the point that you're given. Okay, so we figure out with the point that we're given. Okay, so take a look at this. How do we use the point pi comma 2 to figure this out? Yeah. Uh-huh.
So that means that the highest point that it goes to is going to be 2.
Mm-hmm.
So what I did was I just drew out the graph.
Uh-huh. And you tried it out that way?
Yeah.
So trial and error is the best way to do it. Okay? If you have a circle like this, what is this point? X is 0, y equals r. Right? What is this point here? Negative r, comma 0, right? So which of these functions is going to make us pass through the point pi comma 2? So let's try it out. Suppose we had half x, right? Suppose we had half x. When x equals pi, is y equal to 2 in that case? Here. When x is pi, what is y equal to? Y equals 2 sine pi over 2x. How much is, I'm sorry, pi over 2. How much is sine of pi over 2? Sine of pi over 2 up here, how much is it? Sine of pi over 2 is 1. 2 times 1 is what? 2. So it is the positive version. Okay? If we had tried y equals sine negative half x, right? How much would that have been? Sine of negative pi over 2. There's a 2 here. You would have gotten y equals negative 2, and that doesn't work. Okay? Question?
No.
Okay.